Okay, so let's take the two exercises. Oh, and let me share then my Jupyter Notebook. Share screen. Ba, ba, ba. Share with desktop one. Share. Looks like it's doing the right thing. Okay, excellent. Okay, so the first exercise was ask the user to enter a string. So, ask user to enter a string, and then ask the user to enter a letter, and then print the index at which the letter is located, and then also print the letter preceding and following that letter. And the idea is basically, and I messed up a little bit on this in the problem description. Let me just open up also so I can see here, just in case people have like stuff in the chat that will run by. All right, let's go over this. Excellent. Okay, so the example that I gave was if the string is s equals a, b, c, d, e, f, g, and then we want, oh wait, and we ask, and we're going to say like look for equals c. Now, of course, these two first things we're going to get from the user, but I'm going to like pretend it's not. So what we want to do is find out where is c in s. Where's the letter c in the variable s? So I'm going to say here, right? I'm going to say s dot index of c. And that's going to tell me 2. Now, we saw last time that if I look for something that is there, it'll give me back a number. But if I look for something that's not there, it'll give me an exception. It'll give me an error message. So we're going to pretend that it's better to use find, because find, when it works, gives us a number. And when it doesn't work, doesn't give us an exception, it gives us -1. So what I can do is say here, right, I equals s dot find of look for. So I'm going to find out at what index is that letter located. All right, and then I can say if I equals -1, and print, we can say here, look for is not in S. And sure enough, well, we're not going to get that, right? But then I can say else, if it is there, then what I want to do is I want to print that letter and the letter before and the letter after it. Now there are a few different ways that I can do this, but I'm going to go for the gold ring here. I'm going to say here print, right? Let's say here let's do it this way. Why is this not closing? That's kind of funny. Oh, it's a string. Never mind. All right. So basically what I can do is I can say here, we just do print s of. And what do I want? I don't want s of I, right? If I print s of I, I'm just going to get that letter, C. I can do that actually. I can say here something like, f, I found that at index I. Right? That'll work. Nothing wrong with that. I found C at index 2. Fantastic. But then I can also say print, right? And then I can say its neighbors are at. And then I can do something super weird. I can say S. And then instead of saying I'm going to say I -1 colon I +1. And watch what I'm going to get. Its neighbors are, sorry, I need to do -2. Haha. Did I do -2? No, BC, no, I need to do +2. That's what I need to do. There we go. Now notice this I -1, I +2, there are a few different things that I'm doing here that are kind of tricky. One is that I'm using a slice. And remember, slices are from start colon stop +1. So we go one beyond what we actually want to show. That's why when I did +1 before, it didn't work. So I want to show from everything in S, from I -1 until I +2. All right, that was weird. Everyone's still there? Huh. Zoom just like died and restarted on me. Okay, that was super weird. All right, let's try sharing the screen again, and hopefully it won't cause any trouble. All right. Let's see. Oh wait, you're not stop video? No, video's there. I'll open the chat again just to like make sure that people can tell me what's going on. Let's see. You can't still see. Can you see my screen now? You should be. Big Brother's not like slices. Okay. Oh, good. Excellent. All right. So what I'm going to do here is I'm going to say the slice from I -1. So from what we found, -1, until what we found, +2. Why? Because we want the one before and the one after. Now, could I have pulled them out individually? Yeah, but this is kind of more fun. Now, what happens though if I look for, now I'm going to make this actually interactive. I'm going to say input, enter a string. We'll do a strip here. Why do I do strip? So I remove any white space at the beginning and the end. And I can say look for equals input, enter a letter, strip. Okay, so I'm going to enter A, B, C, D, F, G. And I'm going to look for C. Once again, we get B, C, D. All is good. But what if I say here A, B, C, D, F, G? I look for A. Uh-oh. I found A at index 0. Its neighbors are at, what's going on? Well, let's think about this. So it calculated I is 0. So it said, okay, let's look at S of I minus 1 until I plus 2. And sure enough, we get an empty string. Why are we getting an empty string? Well, what is I minus 1? What is 0 minus 1? Minus 1. And what is I plus 2? It's going to be 2. Oh, minus 1 to plus 2. Wait a second. Minus 1 is an index, right? Index of minus 1 is the final character in the string. We have basically come up against one of these super weird Python sorts of things. So what we have to do is say, wait a second, if the index is 0, then we don't want to go to minus 1. So I'm going to have to put a little if statement here just to sort of guard against things. And there are different ways that we can play with this, but I'm going to try to make this the most straightforward as possible. So I'm going to say here, if I equals 0, well, let's do this. If I is greater than or equal to 0, greater than 0, then we'll do this. Else, what we're going to do is we're going to say print, right, its neighbors are at, I'm just going to say here, S from I until I plus 2. And now when we do this, if I say A, B, C, D, E, F, G, and I say A, it'll give me A, B. So you see what I did here? I basically had to take care of what we call in programming a corner case. And the corner case is basically, there's sometimes we have to deal with what if we're at the edge or an edge case, right? So it's like when your cursor, when I move my mouse cursor all the way over to the left of my screen, right? What should it do? Well, should it go off the edge? Should it disappear? You have to deal with these sorts of things in your programs. So that's if I found the leftmost one. What if I try the rightmost one? A, B, C, D, E, F, G, and let's find G. And it says, oh, the neighbors are F, G. And you might be saying, wait a second. Why did we get an error when it went off the edge there? Well, let's take a look. If we look now at S, so S is A, B, C, D, F, G, and I is 6. So if I say S from I minus 1 until I plus 2, sure enough, we're getting FG, right? So it's getting FG, but we're not getting an error for going off the edge. Well, what if I ask, what is S of I minus 1? F. Okay, so far so good. And what is S of I plus 2? That's an error. This is a weird Python thing. So you cannot request an index greater than the length of the string. But you can have a slice whose index goes beyond the string. So I can say here S of I until I plus 2, or even I minus 1. Watch this. I can say S from I until some really big number. Python's totally fine with that. I actually just discovered this a few years ago. This is not something you want to necessarily rely on all the time. If you really want to, you can have another if or elif clause there to sort of check where we are and what's going on. All right? Questions or comments about this? Okay, if there are, you can keep typing. Otherwise, I'm going to go into the second question. I can always come back to questions as well. No trouble. All right, so now what we're going to do is we're going to ask the user to enter a string, and then ask the user to enter 2 numbers, separate inputs. And then print the string from the first to the second. So now we're going to be basically printing a slice, but we're going to get the first number and the second number. And we're going to assume that these are legitimate indexes in the string, right? And we can, assuming they are this is assuming they are legitimate indexes. So we want to make sure that they're integers. We want to make sure that they're like not too long, not too short, not too big, not too little, that sort of thing. So let's do S equals input, enter string, strip. And I'm going to say here, let's do, I don't know, I equals input, enter, first index. And then we'll say here, and we'll do a strip on that too, why not? And J equals input, enter second index. Why don't I just say first and second? We'll say start and stop. There we go, that's much better. Enter start index. I hate using except here and there, like X and Y and I and J. I'd much prefer to use words that actually describe things. All right, and then if I say here, enter stop index, strip. All right. Jason has a question. I'll get back to that in a little bit. I just want to get through this one first, but then I'll definitely talk about it. So what if I say now, so I want to then check, are these numbers? So I can say here, if start is digit and stop is digit, now what? Then we'll do something. We'll get back to this. And then I can say else, print, you must enter numbers, for the start and stop. Now it would be better to have like, which one was not right, but shh, don't tell my manager, we'll be okay. So now we know that we can turn these into integers. So I'm gonna do that. I'm gonna say start equals an int of start, and then stop equals an int of stop. And now what I wanna do is say, well, are these actually not too high and not too low? So I can say here, if start is less than 0, right? Well, actually, let's do this. Let's do if start, now like, wrote myself into a bit of a corner here, but fine. We want to make sure that it's within, well, let's just do a long like if and elif thing. So I can say, if the start is less than 0, print, start is less than 0. I can say here, elif start is greater than len of s. This actually be greater than or equal to the len of s. Then we'll say print, all right, stop is too big. Oops, let's go there. We can say here, elif stop is less than 0, right? So this all of a sudden starts to repeat itself a little bit. And is that annoying? You bet it's annoying. Welcome to the world of programming, folks. Oops, and we can say here, if stop is too big. What else can we have? We can have like, make sure that start is less than stop. Elif start is greater than stop, print, right, start is greater than stop. I think then we can stop, as it were. And then we can say else. If none of these problems are there, then what we can do is we can say print, right? So we'll say here, well, let's just do s from start until stop. Pretty good, I think. Let's check this a little bit. All right. So I'm going to, oops, else. Why is my else a problem? Because I didn't close those parentheses. Okay. So if my string is going to be A, B, C, D, E, F, G, and now I can say from 2 until 5, C, D, E. And if we think about it, okay, so we've got A, B, C, D, E, F, G, 0, 1, 2, 3, 4, 5, 6. So we're going to have starting index 2, so that's C, until and not including index 5, that's F, C, D, E, a massive success. Oh, did I use start and stop? Wait, start. Oh, thank you. Thank you. Stop. Okay, very good. Thanks. Didn't affect us yet, but it would pretty soon. What if I say here A, B, C, D, F, G, and then I say H and I, say, sorry, you need to enter numbers. What if I say here, like, A, B, C, D, F, G, and I say here the start is 10 and the stop is 5, it'll say 10 is too big. Oh, well, it's definitely too big. It's also bigger than starting out A, B, C, D, F, G. I say 3 and 4. Oh, from 3 to 4, that worked. I want to do 4 and 3. D, F, G. Okay, we're not going to spend all day on this, right? But you can see that we can have a whole bunch of tests here. And this is not uncommon. You want to check your user's input in all sorts of different ways. Now, could I have just like have a huge and, if this and this and this and this and this, or this or this or this or this, then we'll give an error message? Yeah, I prefer to have it sort of in many different lines so I can trace through what's going on. And if I need to add another clause, I can add that. That's not an issue. All right, I'm gonna go back to Jason's question now. And then if people have questions about this, I'm happy to answer it as well. So Jason asks, and by the way, I have to remember to read the questions out. People have pointed out that in the recordings, the chat is not included, and that is true, and I'm sorry. So Jason asks, don't we have to be careful about comparing the index of a string to the len of the string, because the len is one more than the last index? Yes, indeed, we have to be careful about that. It has to be a check of like greater than or equal, not greater than. So it's a problem, like for example here, if I say here A, B, C, D, E, F, G, so we know that the length is 7, but the highest index is 6. So if I say here, I want to do, well, actually this won't be a problem, I guess, because it's, never mind. Okay, so if I do like, let's do this, right? S, so len of S is going to be 7, and S of 7 is going to give us an error message. So we definitely need to do greater than or equal to the len if we want to check for errors like that. Okay, other questions or thoughts? Yeah, so The negative numbers thing is a little bit tricky in a variety of ways. Number one, the whole issue of like find with -1. But even if we ignore that, if we're checking here for is digit will only look for positive numbers because it's only going to look for the digits 0 through 9. A sort of more sophisticated way to do this would be to just try to turn them into integers. And if you get an error, to trap that error. We haven't talked about anything even close to that in this course yet, something known as exception handling, that you can do that. Like, I'm going to try something. If I get an error, okay, I'll deal with it and I'll fix it. Segregating negative numbers and string inputs for start and stop. And what you could do, I'm not sure exactly what you're talking about, but like we could have more if statements. Like we could say if it's like here I did less than 0. Right, that might help. I hope that answers your question. If not, let me know. Oh, and the question was, I guess I need to read this out loud, how to segregate negative numbers and string inputs for start and stop. Okay, I'm going to try to get used to doing that. Okay, so let's start on today's topic, which is loops. All right, and we're going to try to talk about 3 different types. Oh, could or statements work too? It's better to have all those elifs, Christian asks. And this is not a technical question. This is a question of style, you know, or taste, you know, my taste or bad taste. No, basically, I prefer to have a lot of if and elif statements, with each one being really short and easy to understand, rather than having this huge, long list of ors and then having to sort of figure it out. Okay, I'll look at the forum for your question, Gangly. Thanks for mentioning that. Okay. So we're going to talk about loops, and we're going to try today to talk about 3 different types of loops. Well, actually, Python only has 2 types of loops. It has for loops and it has while loops. And we're going to talk about both of those. And in for loops, we're going to talk about looping over strings. We're also going to be talking about looping a number of times. I think we can cover this all today. If not, we'll continue next time. All right. So here's the idea. Let's say I say here S equals A, B, C, D, E. And I want to print out all of the elements of S. Well, we know how I can do that, right? I can say here print S of 0, and print S of 1, and print S of 2, and print S of 3, and print S of 4. And if I do this, sure enough, I get all of the elements, all the characters of the string S. There's nothing technically wrong with what I just did. But I think you can understand, looking at this code, oh my God, what a pain to write, what a pain to maintain. And what happens if we add a letter? Oh God, now I've got to go in there and say print S of 5. And this violates a core idea in programming known as dry. Don't make typos. Don't repeat yourself, right? And this dry rule, people talk about drying up their code, meaning they find repeated aspects to it, places where they repeated code, and they try to dry it up. They try to combine it in one way. And the idea is that you shouldn't have to write so much. Larry Wall, who invented the Perl programming language, once said that good programmers are lazy. And by lazy, he meant let the computer do the hard work. Don't do the hard work yourself. So what am I trying to do here? I'm basically trying to say, you know, print each character of S, starting at the beginning and ending at the end, right? Sounds, you know, pretty straightforward. So for this, I'm going to use a for loop. For loop executes some code for every element of a string. Meaning, what I'm going to be able to do is say, here's a string. For each one of the characters in it, please do the following. And here's how the syntax looks. I'm going to say for one character in S, print one character. So what's going to happen here? Well, first of all, let's look at the results. And sure enough, it has printed all the elements of S. But let's talk about what's going on here and how it's working. So for is a special word. It's what we call a keyword in Python. And for turns to S. It turns to this string and says, hey, string, do you know how to operate inside of a for loop? What we would call, you know, for asks S, are you iterable? Can I iterate over you? Can I run this sort of thing one at a time? And S says, yes. So then for says, okay, if you are iterable, then give me your next one, and your next one, your next one, like your next thing. And S says, okay, here's my first character, my second character, my third character. And each one of those goes into the variable one character. So the first character from S is assigned to the variable one character, and then we run this body. The body of the loop here is one line, but it could be as many lines as we want, as long as they're all within that indentation. And then we go back to the top, and S gives us the next thing, which is assigned to one character, and then we run the body. And we go back to the top, and this happens again and again and again until when? Until S says, I'm done, no more. And at that point, the for loop says, okay, thanks very much, we're done. And it exits and it continues after the for loop. So if I were to say here, print before, and here, print after, we'll see that it prints before, it goes through each of these iterations, and then it leaves the for loop quite nicely and quietly and prints after. Now, very, very important. I chose this variable name one character. The choice of variable name is 100% up to me and has no impact whatsoever on what is assigned to it. So if I were to say like here, if I were to say like for, 1 gigabyte, right? That is not somehow magically going to tell the for loop or S, please place 1 gigabyte in each iteration. No, I'm still going to get A through F. So the naming of variables and the naming of functions in Python is totally for people to understand what you're doing. And you can choose whatever variable names you want, but you should try to make them understandable to people. Now, if you've ever done programming in another language sort of thing, then you've probably seen for loops that look a little different. In those languages, your for loop is going through the indexes. Give me 0, first 0, then 1, then 2, and 3, and you're doing all these calculations. In Python, we do not have this at all. Such a for loop does not exist. For loop is very easily for some variable in some collection. It's always going to be like for variable in collection, right? And then body line 1, body line 2, and so on and so forth. How does a for loop know that one character refers to a letter of the string? That's Invar's question. Excellent question. The answer is magic. No. Okay, we could hope. No, what happens basically is the for loop is just a very lightweight container. It does not know what S does or what S is going to return. What's happening is the for loop is turning to S and saying, give me your next thing. And it's up to us as developers to know that when we put a string into a for loop, we're going to get one character at a time. By contrast, if I put a file object, and we'll talk about those in a few weeks, if I put a file object into a for loop, I'm going to get one line of a file at a time. If I put a list into a for loop, I'm going to get one element of the list at a time. So every type of data that knows how to be inside of a for loop also has defined behavior inside of that for loop. So the for loop, this is known as a protocol or an API, where basically the for loop has a certain way that it behaves, and any object that knows how to behave in that way can sort of be stuck into a for loop. But it's up to the object. It's up to the string, and all strings will do the same thing. Okay, so hopefully that makes it a little clearer. And I know it's kind of weird, like we're depending on it. So you could have no, you have to come up with a name, but you can call it whatever you want. You can say here, for thingy in S, print thingy, and it'll still work. Right? So the variable name is totally for us. Don't call it thingy. Try to come up with something a little more useful. So I'll tell you, it's very, very, very traditional to use I and J for iterators. I really dislike that. Really dislike that. I much prefer to have longer variable names that say things. And I used to just say like word or letter. And maybe people can confirm this, but I found in my international travels and teaching that people who, from English is not their native language, it's much clearer to say one thing, one letter, or one character, or one line, rather than just saying character or line. It just accentuates a little more that I'm only dealing with one at a time. Hopefully I'm right. I've been doing it for a few years, and so far so good. Okay, so I can iterate over a string, and then I can do all sorts of cool things in it. For example, let's say I have S here. We know that I can say is C in S, right? And this will return true or false. And we know it's going to return true, yeah, because there is a C in S. But I can implement it myself. I can say here, like look for equals C, and say for one character in S, if one character equals look for, print, I found one character in S. And sure enough, right? So it's not exactly the same as in, But what is in doing, right? We don't know the implementation because it's deep inside of Python. But basically in is running a for loop. Starts with the first one, then the second one, then the third one. And when it finds what it wants, it returns true. Not exactly what I showed you, but pretty darn close. So for loops are super, super useful. They allow us to go through one by one by one, each of, at this point, the characters in a string, and find them in that way. Let me show you another example. So, or a more useful example, perhaps. So watch this. Let's say I'm going to say here, s equals input, enter a word. And I can say here now, so I want to print, right? So let's count vowels in the user's input. Right? Does it iterate to see a break? No, I did not. It does not. So Mike asked the question here. Does it iterate to C and then break out? In this particular case, the way I did it, no, it's going to keep going. So if I have more than one C, so for example, if I have S equals ABCD, 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 CCC, it's going to print it several times, right? So we're going to talk, we might have time today, I hope we will, to talk about how to break out a loop early if you get what you want. All right, so let's say I want to count vowels in the user's input. I can say here, like, count equals 0. And then we can do this. We can say here for one letter in S. If one letter in AIOU, then we'll say here count plus equal 1, right? Remember, this means add 1 to the count variable. Then we can say here print S contains count vowels. And so I'm going to now say, elephant. And it says elephant contains 3 vowels. Because what happened here? Actually, let's see. I'm going to start this up in the Python tutor. I think that this is a good time to return to that site. It's really nice for getting insights about this stuff. Okay, let's see. Fire this up. All right. So I'm going to just paste the code from here. Now I'm going to visualize execution. Okay, first thing, set count to 0. So we have a global variable here, count, set to 0. That says, okay, enter a word. So I'm going to say here, once again, elephant. So now you can see where we are in the code. We're about to start the for loop. Count is 0, and S is the string elephant. So it's going to say for one letter in S. So the for loop is going to turn to S, say, are you iterable? The answer is yes. Okay, so one letter is a variable just like any other, and it's a string, the string E. And then Python asks, or we ask in our code, is one letter in AIOU? The answer is yes. So it's going to add 1 to the count and goes back. And now it says to S, give me your next thing. And sure enough, there's an L. Is that a vowel? No. So we go back. Next thing, E. Yes. P, H, A, that's a vowel, and T. We're done with the loop, so we exit from it. And then we print out the result, and we now know that the count is 3. It is hard to exaggerate how often for loops are used in code, right? Just a few different examples. You're running a whole lot of programs on your computer right now. You're running Zoom, you're running maybe a web browser, maybe you're running Python, maybe you're running a terminal window, maybe you're running your mail program. How does your computer switch between all of those programs? It's doing a for loop. Give a little bit of time to this, then a little bit of time to this, then a little bit of time to this. It's going 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, or however many processes there are. Let's say you are, you've got a web browser open, right? And so a web browser will go to a page and it'll say there are 5 images on this page. So it will download all 5 images, and very often it'll do that in a for loop. First do the first one, then the second one, then the third one. Anytime you're repeating something across multiple pieces of data within a collection, that is a for loop. And it turns out to be just incredibly, ridiculously useful. And the number of times that I use for loops, like literally, it's hard for me to imagine a program that does not include a for loop, just as it's hard for me to imagine a program that doesn't include an if statement. These are like super important cornerstones in all of programming. Okay. Any more questions until here? Okay, and if there are, obviously, like keep them coming, and we'll I'll take a look. Okay, there we go. All right, but someone before, who was it? I think it might have been Mike. Oh yeah, Mike was asking like breaking out of the loop. So I'll talk about that in a little bit, but I first want to look at one other thing. That's right. So let's say I'm in a great mood. Why not, right? I'm in a great mood, and I want to print, hooray 5 times. So print, I'll just do this 5 times. 1, 2, 3, 4, 5. And sure enough, this works. Excellent. But you are probably already thinking, I hope, wait a second, we're doing the same thing multiple times. Surely we could use a for loop for this. And your instinct might be to say, what if I do for, like index, or for number in 5, print array. Great thinking, will not work. And the reason is that the for loop turns to the number 5, turns to the integer 5 and says, are you iterable? And we get an error. No, actually, integers are not iterable. Now, why they decide this in Python, I'm not entirely sure, but it is the case. So if we want to do this, we actually need to use a function. And this function has all sorts of cool things you can do with it. We're going to ignore most of those right now. And it's called range. And if I say here for number in range of 5, then it works just fine. So to iterate over each character in a string, use, oops, no, come back. It'll be, for, one character in S. But to iterate a certain number of times, use, for one item in range 5, let's say, or range n. And then it will execute that number of times. Oh, excellent. Dory has a great question here. Is the range 1 to 5 or 0 to 4? Fantastic. So you've already figured out that this range isn't just like doing something 5 times, but it's actually giving us a number. And so let's take a look. This number here, I'm going to do an F string here. I'm going to say here number. And turns out it is indeed 0 to 4. So range is going to be from 0 until and not including 5. And so you're starting to see, hopefully, some of the consistency here in Python. Just as in slices, the top index is up to and not including, here range is up to and not including. Okay, so we're always going to start counting with 0 here. Now, this then offers all sorts of possibilities also, because I can ask the user how many times they want to do something, and we can do it. I can ask, the user, there's so many ways, so many places that I can use this. Really, it's hard to exaggerate it. All right, so we've got looping over a string where we get character by character. We've got looping over a range where we get the numbers 1 by 1 by 1. Okay, so let's try this. Let's do a little exercise. Might be a little more than a little, but we'll try. So what I want you to do is ask the user to enter their name and then print, iterate over each character in the name. Let's do it this way. Let's do this. You know what? Let's do something a little different. Ask the user to enter a word containing only digits. Okay, and then what I want you to do is sum the digits in that word. So if the user enters 1, 2, 3, you should print 6 at the end. Okay. So I'll give you about 2-3 minutes to work on this. I want to emphasize, I don't usually give this little time on exercises when I'm teaching a class, but I'm just trying to balance how much time we have and still have you do something while we're here together. So try to work on this for a few minutes. If you don't manage to get it, it is totally okay. You should take your time and think about it. If you want, as bonus, check to see if each digit is really a digit. I'm going to do that when I implement it, but you don't really need to do that. So give that a shot, and 2 minutes or so, we'll go over this together, review it, and then we'll talk about some more loopy types of things. Okay, and meanwhile, people have questions or comments, feel free to put them in the chat. Don't hesitate. All right. Let's go over this now. And again, I'm not trying to like pressure people. These things can take time. I realize that. Okay. So here's what I'm going to do. I'm going to say, let's get a word from the user. I'll say here, well, just s equals input, enter a number. Let's do that. I'll even use strip. So now what? Well, I want to sum the digits. So I'm going to say here like total equals 0. I'm going to start off with 0. Good place to start. And I'm going to say here for one, let's say character in S. And it's important to say also that when you're writing a program, you want to start with the easiest, simplest thing first that gets you toward your goal. It doesn't need to do everything. So I'm just going to say here, print one character. All right, so far so good. So I say here 1, 2, 3, 4, 5, prints 1, 2, 3, 4, 5. Very good. Well, now what? Well, now I want to add that to the total. So I'm going to, at the end, I guess I want to say print total equals total. So if I do it now, I say 1, 2, 3, 4, 5. There we go, total equals 0. So far, so good. So now what? So now I actually want to use that and add it. So I'm going to say here, instead of printing, I'm just going to say total plus equal int of one character. So if I say 1, 2, 3, 4, 5, it's going to say total is 15. Fantastic. So this actually worked. Now I can also add a little bit of a check in there. I can say here, if one character is digit, then add it to the total. I can say else print ignoring character, one character. Let's say ignoring non-digit, one character. Say 1, 2, 3, ABC, 4 exclamation point, that's 4 exclamation point 5. See, and it seems to work. I'll just post this in the chat also so people can look now. Oh, not all panelists, all panelists and attendees. They always do that by default. Okay. All right. Questions or comments about this? So a for loop is always when you want to go through, at this point, a string, one by one by one, and do something with each element. Okay. And a for loop with a range is when you know you want to do something a certain number of times. And there'll sometimes be overlap there, right? So sometimes you might want to go through each letter in a string, but you might want to be keeping track of where you are in the string, in which case it might be easier. And there are other ways to do this in Python also. It might be easier to use the range on the length of the string. Where I could do that, I could say here, if S is this, well, let's do S equals A, B, C, D, E, F, G. I can say here for, right, let's just do index in range len of S. Right, and so now I can say here, index is index, and then S, current character is S of index. And so you can see here that by iterating over the range, now this is where it all comes together. Len gives us one more than the maximum index. Range goes up to, but not including, whatever number it was given. And it all fits together well. So by doing for index in range len of S, I can get the indexes of the characters in S. By the way, you will almost certainly never want to do this. On occasion, maybe. But in actual real-life Python programs, how often do you care about the indexes? Almost never. You care about the actual letters. And this is a big difference between other languages in Python, where in those other languages, when you do a for loop, you need to keep track of where you are, what index. And in Python, it's like, why do you care about the index? What's really important is the string. Right? Like a C language, you use the index to get to the character. And in Python, it's like, here's the character. You want the index? Fine, you can calculate the index, but that's not nearly as important. Okay. There is one other type of loop. And as I said before, there are two types of loops in Python, for loops and while loops. And while loops are just like if statements, except that so long as the condition is true, the loop executes additional times. All right. So in an if statement, let's say I say here something like this, x equals 5. If x is greater than 0, print x is x. And then I'll say here x minus equal 1. Reduce x by 1. And so I run this. X is 5. Is x greater than 0? You bet it is. So we're going to print that f is this, and then we're going to say x is we're going to remove 1 from x. And so now if we look at it, x is actually going to be 4. So this is the if version. The while version, we just change one word here, while. Look what happens. It runs many times. What we're doing here is we're saying, so long as this is true, execute this code and come back to the top. And then execute this code and come back to the top. Execute this code and come back to the top. What if you don't have this line, x minus equal 1? Well, then x will continue to be 5 forever, and you have what is known as an infinite loop, right? An infinite loop means, right, never stops, goes on forever. Fantastic if you bill by the hour, not so good in almost all other cases. 2 nerd jokes about infinite loop. Number 1 is that I believe Apple's headquarters used to be, might still be, at 1 infinite loop. Like they actually, I think, got the, I don't know which city it would be, like Cupertino or something, to rename this like the street for them. Number 2, there's some famous programming books. Is it here actually? I think it is actually. Let me just see it somewhere. And it's there. Let's just take a look. This is my Lisp book that I got back in college like 30 years ago. Really haven't referred to it very much since then, but it's like such a classic. So I'm just going to double check that this is actually here. So if you look in the, no, I guess not. Okay, I'm sure that it was in here. Fine, I'll find another time. But basically, it was well known in many programming books that under loop, it would say loop infinite, C infinite loop in the index. And then, of course, infinite loop would say C loop infinite. Okay, there you go. That's how programmers like to joke around. Sad, but true. So where are you going to use a while loop? You're going to use it when you don't know how many times you need to execute it. You just know when it needs to stop executing. So it could be that it'll run none, like it won't run at all, run 0 times. It could be they'll run once. It could be they'll run 10 times. It could be run 1,000 times. You just don't know. So you can do something like, so long, you can think of a while loop as, so long as something is true, do whatever. So for example, so long as there are still files in this directory, delete them. Or so long as there's still files in this directory, print them. And then what will happen is you can do this while loop and check, do we have any, do we have any? Now, why would you do that rather than a for loop? So a for loop would be great for printing all the files in a directory. Go through each file directory, print it, print it, print it, print it. But a while loop can handle more easily if new things are coming in, right? If all the time you have new files there, then you might want to use a while loop. There are definitely times when it's not obvious which to use. So here's another analogy that I sometimes use with people to distinguish between for loops and while loops. So if any of you have children, right, and I'm not this sort of father, I'm not, but it's a useful analogy. So a for loop is like saying, I want you to pick up every piece of clothing from your floor, right? Because the for loop is for each one of these. The while loop would be, so long as there are clothes on your floor, pick them up. Okay? Slightly different semantics there, but both very useful at different times. Okay? All right. So how else can I use a while loop? Well, what I could do is I could also say, well, while loops are very useful, as I said, if I don't know how long something is going to go on. But we're going to need another piece of code, another control structure to really make while loops useful. And those are break and continue. And these can be used, so these words can be used in either for or while loops. Break and continue. Break means exit the loop right now. And continue means exit the current iteration, go on to the next one. We could say even continue with the next one. So let's take a look at how these compare. So if I say here, S equals A, B, C, D, E, F, G, and I say like look for equals, let's say D. So if I say now for one letter in S, so we're going to go through S one letter at a time. I'm going to say, let's do this. If look for, so let's do this. If one letter is look for, then break. So if we encounter D, stop the loop right away. Otherwise, we're going to say print one letter. And so sure enough, we get to A and B and C. And then what happens? Well, one letter is now D. And we say if one letter equals look for, that's D. Yeah, it is. So break, end of loop. That's it. So if I say your print start, I guess I don't need an F string there, print end. Start and end, right? Start, A, B, C. Oh, we broke out of it, end of loop. By contrast, if I were to say continue here, right? So stop this iteration, but go on to the next one. So now we're going to have A, B, C, E, F, G. All right, so continue didn't say stop the for loop. It just said this iteration, the body, we're just going to zip right up, back up to the top, and we're going to continue with the next one. These together, for loops, while loops, break and continue, give us incredible power to go through things one at a time, or to go through things again and again. Watch this. I can say here, total equals 0. For, let's just do I in range 3. Let's do n equals input, enter a number. If n is digit, then we'll say here, total plus equal int of n. So we're going to get the number from the user. We're going to check if it's a number, if it can be turned to a number. If so, we're going to turn it to an integer, add to the total. Then we can say here, print total is total. So I'm going to say here 10, 20, 30. And sure enough, the total is 60. So far, so good. So I was able to loop over this. And instead of having 3 times in a row, n equals input, if n is digit, and so on and so forth, I was able to really compress, dry up my code and make it much more readable. But what if I don't know how many numbers the user is going to give me? Then I can use a while loop. I can say here, this is going to seem crazy, while true, an infinite loop. Be very careful when doing these. And I can now say, and I'm going to say here, total equals 0, n equals input, enter a number. I can say here, if n is digit, total plus equal int of n. So far, exactly the same as before. But I can also say else break. If we got a non-number, stop asking and leave the loop. This turns out to be a really common paradigm. Really, really common. And then I can say here, print total equals total. And now how many inputs am I going to get from the user? I don't know. It's up to the user. And so now I can say here, 10, 20, 30, right, 100, 5126, press enter, and there we go, we exited. Why did enter exit from the loop? Because if I just press enter, we get an empty string. If I get an empty string, that can't be turned into an integer. So it's not is digit, and we break out right away. This is super powerful. This means now I can take any collection at this point of string and go over it one by one by one. That's great. It means I can ask for input from the user any number of times, either a set number of times set in advance, or a variable number based on their inputs. Questions or comments about this? Okay. So let's do one more thing here. And yeah, let's do one little exercise. Oh, wait, what happens if there's an infinite loop? Bad news. So if there's an infinite loop, basically, nowadays, modern computers will not lock up, but your program will lock up. Your program will try to run here. I'm going to do this inside of a terminal window. Let's just do this here. Okay. So I'm going to say here, I'm going to go to Python. I'm going to say here, while true, print And I'll just say hello. And it's just going to run and run and run until I stop it. Now, when can I stop it? I can use Control C to stop it. Control C is pretty typical, but not always will it listen right away. And if you're doing more than just printing, it might use resources on your computer. And so it might use memory. And so your computer might actually run out of memory. Your Python might run out of memory. Infinite loops are generally a bad idea. This is like a controlled infinite loop. Larry asks, could you put the is digit in the while statement instead? No, not in very, very modern Python 3.8, which came out a few months ago already, which I can't remember. I don't think I have it running on my computer yet for a variety of reasons. No, there's no, Ganguly, there is no error message if there's an infinite loop. You are just sort of stuck. I mean, you might get an error message that your computer's out of memory. That would be an error message. But if you're just running an infinite loop printing things, no, you won't get an error message. In fact, it is one of the things that you learn in computer science theory, that there is no way for a program to check if another program has an infinite loop in it. So assume I have a program that has an infinite loop, and I have another program that checks that. And it can identify, is there or is there not an infinite loop? So the way the theory works is basically, if you run that program on its, if you run the program for checking for infinite loops on itself, then if there is an infinite loop, it'll stop. But if there's no infinite loop, then it'll continue. And basically you end up with a paradox. So there's no way for the computer to identify if there might be an infinite loop in advance. But if it happens, you'll know. Anyway, back to Larry's question, can you put is digit in the while statement instead? Not really. In Python 3.8, they have a new way of assigning, and it makes it a little easier to do this. You would say basically while n colon equal input, enter a number. And then you'd say like, on and on, if n is digit. And this basically says if we get an empty string here, then we'll stop. But I don't think we can say, I don't think there's a way, like maybe we could do like, is digit. I think that would work, but everyone would kill you because it's so hard to read. And anyway, this new operator, which we've not talked about, which is called the walrus operator, which is both assignment and an expression, people are very, very divided about. It caused like a huge firestorm of protest and conflict inside the Python community. So even if that would work, I don't suggest it. Over time, maybe people will be a little happier about doing that, but for now, definitely not. All right, let's see if we can do a quick, what's it called? A quick exercise now, and then we'll I think pretty much have to sum up for things for this week. But loops, like really, really, really super ridiculously important, just as important, I'd say, as if statements and so forth. So let's do this. Let's have the user. Oh, let's do this. Okay. So we saw before, and I think I even showed it to you. I'm going to paste it in right here, like counting. Here we go. Counting vowels. I'm just going to copy this to the bottom here so you can take a look at it as well. So this is code that counts vowels in the user's input. And that worked just fine. What I want you to do now is write a program that asks the user to enter any number of words. When they enter an empty string, stop asking. Stop asking and print the number of vowels in all words entered. In other words, I want to do the same thing as we did here, where we were counting the vowels in the word, but here we only counted in one word. Now I want to count in multiple words. How many words? However many the user gives us. All right, so I'll give you like 2 minutes to work on this. My guess is that it's too short of a time, and I feel bad about that. Yeah, I mean, I do feel bad about it. I'm just trying to think if there are like any better alternatives. I'll give you time at least to think about how you might strategize on this, and then I'll show it to you. If there are any more questions, we'll go over that together as well. All right, tell you what, I'm gonna go over this now, and could be that I was like really crazy exaggerating how much I could. Okay, should have come up with something a little easier. So here's the basic idea. I want to write a program that lets the user enter any number of words. I want to enter an empty string to stop asking. So how am I going to do that? Well, I'm going to say here while true. Again, potentially dangerous. We got to like catch this right away. I'm going to say here s equals input. Enter a word. Strip. And I can say here if s is the empty string, break. Right? So stop when we get an empty string. What if we don't get an empty string? Watch what I'm going to do. I'm going to just copy this from here. I'm going to indent it also so it'll actually work. You know, that's useful. So I'm going to say for one letter in S, if one letter is A, I, U, count plus one. So I'm going to say plus equal one, so I'm going to count equals 0. And so what we're doing is we're going through the word that the user gave, counting the vowels, going back up to the top, getting another word, counting, going back to the top. And then I can say here at the end, even count, do this. So here, so if I say now, you know, hello, and we can say here, you know, I don't know, text, and we can say here, I don't know, pretend, and octopus, and elephant, and enter. And it contains 11 vowels altogether. Oh, I guess it did, so S, fine, because it was an empty string. That was a silly thing right there, but fine. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What do you know? The computer is right. And while this is like a toy example, I hope that it's starting to show you the potential for these loops. We just go from one thing to another thing to another thing. We can ask it for information. We can query the user, all sorts of stuff. Questions or comments about this? Okay, so just to summarize, we saw for loops, right? Iterate over, in this case, a string, right? But we're going to see more stuff in the future. While loops, you know, sort of like if statements that, you know, repeat. And then we have break. We also had like a for in range of an n. So, you know, iterate n times. And then we also had break, stop the loop, and then continue, you know, stop the iteration. And again, these very small, seemingly simple building blocks are big conceptual and big useful technical ideas. So we have, believe it or not, finished not only this hour, but we finished the string, dealing with strings. Not that we're never going to use strings again, but next week we're going to start talking about lists. And lists are a different data structure. And you're going to see that they're very similar to strings in many ways and very dissimilar to strings in other ways. And we're going to keep marching through a bunch of different data structures until you see that we can, with these simple data structures, I'll tell you right now, strings, lists, tuples, and dictionaries do a lot. We can organize our data, we can sort through our data, we can find things, we can store things, all sorts of really cool stuff. So with that, I think we're going to stop for today. I will post this video hopefully today, maybe tomorrow night, probably today, in the like dashboard, online store, whatever. I will put some homework problems probably Sunday morning. If I can do it tomorrow night, I will, in the forum. Keep asking questions, keep posting things, keep telling your friends about the course. And thanks everyone for coming. I will see you next week. Have a great weekend, everyone. Thanks again.